Hello students, welcome to the Access Classroom. So today we are going to start our first lecture, which is about differential equation of first order. So first of all we have to learn what is order. Okay, and what is the differential equation? A differential equation is represented as dy dx equals fxy. Fxy means the function of xy. It is also represented in the form of m dx plus n dy equals to 0. In this form we can also represent this. Now we have to know what is order and what is degree. Well, order is, for example, we take this equation d square y by dx square plus dy by dx plus 1 equals to 0. Now focus on this differential equation. Here the order here is, for this equation, the highest order is 2 because it is the highest power of that differential, that is dy by dx, that is 2 in this, for this equation. So the order is here the order is 2. Now what will be the degree? The degree will be the highest degree of the highest order. That means the order here is 2 because it is the highest order in this equation, that is 2. For this thing it is 1 but it is not the highest. The 2 is the highest, so order is 2, and degree will be the highest degree of the highest order, which is for the equation, that is for the second order thing. Here the degree of this is 1, so degree equals 1. Now we have to learn the exact equation. So what is an exact equation? Well, we have first written that here is a differential equation. If we take this kind of differential equation, m dx plus n dy equals 0 in this form, then if we do partial differentiation of this m, here m and n both are the function of x and y. Okay, so m here in this equation, m and n are the function of x and y, and if we do the partial differentiation of m with respect to y, we will get some value, and if we do partial differentiation of n with respect to x, we will have some value, and if these two values are equal, then only we can say that the equation is an exact equation. So for being an exact equation, the differential equation for being an exact equation, we have to satisfy this condition that partial differentiation of that m with respect to y is equals to partial differentiation of n with respect to x for this kind of equation, that m dx plus n dy equals 0. For example, suppose this is an equation given that e to the power x sin y dx plus e to the power x plus 1 cos y dy equals 0. So here if we compare this equation with that form m dx plus n dy equals 0, here we can see that m equals to e to the power x sin y and n equals to e to the power x plus 1 cos y, which is e to the power x cos y plus cos y. So now if we do the partial differentiation of m with respect to y, that is delta m by delta y, we will have e to the power x cos y, and if we do partial differentiation of n with respect to x, that is delta n by delta x, we will have e to the power x cos y. So we can see that here the delta m by delta y equals delta n by delta x. Hence, the given differential equation is an exact differential equation. So, in this way, we can prove that this equation is an exact differential equation. But what about its solution? For the solution of an exact differential equation, we have the formula, which is the formula is integration m dx y constant plus integration n not containing term of x dy equals c. Here c is an arbitrary constant where c is an arbitrary constant. So this is the formula for the solution of an exact differential equation. So let's see what it tells. That the solution of the exact differential equation will be integration of m dx, where the term of y will be constant. If we consider that previous equation, which was e to the power x sine y plus e to the power x plus 1 cos y, e to the power x sine y dx plus e to the power x plus 1 cos y dy equals 0. Here we can see the m, here the m1, where the term of y is sine y with e to the power x. So if we apply this formula for soluting this equation, we can have integration of e to the power x sin y plus integration dx plus integration of n. Here n is e to the power x plus 1 cos y, but here is a condition is n not containing terms of x. That means if we divide the n into that, n equals, we know, e to the power x cos y plus cos y. So for this integration part, we will only write cos y, because in this part e to the power x is a term of x. So this part contains a term of x, a function of x. So we cannot write it. We will only write this part, which is cos y dy equals c. C is an arbitrary constant. Now if we integrate this, here the term of y, the function of y, will be considered as a constant, so it will constant and it will be sin y, and now integration of e to the power x is e to the power x plus integration of cos y is sin y equals c. So our solution is e to the power x plus 1 sin y equals c. So student, I think you can understand now what is an exact equation and how we have to solve it. So always remember, for a differential equation in this form m dx plus n dy equals 0 to be exact, we have to satisfy this condition that delta m by delta y equals delta n by delta x. If this is satisfied, only then it is an exact equation. But if it is not satisfied, it is not an exact equation. If it is an exact equation, then we will use this formula written above to solute the differential equation. So students, we will meet in the next video. We will discuss about the non-exact equations and how to solve them. So till then, goodbye.